Hey guys, Mr. Bouchard here, and today I'm here to talk to you about phases of matter. So in general, what are the characteristics of solid, liquids, and gases? All right, so these are our three phases of matter. All right, and if you look at this picture here, perfect example of how each of these phases of matter look. The first one, because you see how it's packed, it's definitely a solid. All right, nice and tight material. Particles are close together. They don't move around freely. All right, so if you look at water, or liquids, they tend to have a little more space between them. All right, the particles tend to move around a little bit. And the gases, lastly, move around the most. They bounce all over the place, just like the gases in the room surrounding me. Okay, so let's talk about these and how they work. So solids, they have a definite shape and volume. All right, so you can see this is obviously you can see little particles that make it up. They come together in this case, and they're making a cubic solid. In volume, they take up space. In solids, particles are fixed in place and are closely packed. All right, so you notice that with solid materials, the particles just wiggle in place and that's it. They don't move around freely. They're fixed in place. Okay, liquids on the other hand, the particles in the liquids end up moving around. They can switch places. It does have a volume. However, it takes on the shape of the container here. Right, so it has no shape in general. If you just pour water on the ground, it's just going to flow all over the place. So it will only have shape if you put it in a container and take the shape of the container. So we just say it has no shape. The particles are closely packed but can move freely. All right, so there is a lot more free motion in water of the particles, and they do move around quite. And you see this especially when you have boiling water. Because again, you see the particles kind of moving all over the place. Gases, on the other hand, the volume can change according to the container it's in. Okay, gases will kind of take on the shape of the container. Once again, just like the liquid, except it will take the whole shape of the container. So, like, good example, when you get propane for your barbecue, the propane spreads out into the whole container that you get it in. So again, it has no shape. Takes the shape of the container it's in, very much so, more so than liquid does. And the molecules move freely around. Okay. And once you open the valve on, say, a propane thing, that's why you got to be really careful with them. The gas will leak right out. It does move around freely, and it's very flammable, so that's why the danger of it. Gas particles can spread every direction. And they do spread apart in every direction, as I mentioned. All right. Can substances change state? Yes. All right, you know this. Ice cream, the minute you get it, you gotta start eating it. If you don't, it's gonna melt. It's gonna turn into a liquid. All right, so what processes change as the state of the substance changes? All right, so melting is one example of a phase change. All right, and temperature obviously is the major thing that changes there. You're heating up the ice cream, that's why it ends up melting. All right, you took it out of its cold environment that it was in when it was below freezing point. Freezing, on the other hand, you're doing the reverse. So you put something in the freezer, you're taking the heat out of the object and cooling it down to below freezing point. Boiling, so again, you're heating the object up to raise its temperature, and obviously it's turning from a liquid to a gas. Condensation is the reverse. Again, you're removing the heat from the object and you're cooling it down, going back from a gas back to a liquid. Okay. All right, so you must know the phase changes I just kind of stated. All right, so melting is a solid changing into a liquid. Freezing is a liquid back into a solid. Vaporization, also known as evaporation. All right, vaporization is used with any material. Evaporation is only used with water typically, but it's a liquid changing into a gas. And condensation is a gas going back to a liquid. All right, just like the water droplets on the outside of your ice water glass that sometimes form. And then sublimation is a solid to a gas or a gas to a solid. It skips the liquid phase. All right, perfect example of that is dry ice, which they use in refrigeration and in shipping things through the mail that they have to keep cold, because you won't get that liquid mess with dry ice. It just turns right into a gas and that's it. All right, so how does the solid liquid states of a substance compare? All right, so liquid, the molecules move and are more loosely packed, whereas a solid material, they're more fixed in place and they're tightly packed. So exactly opposite. Gases actually more so than a liquid, right? So just so you understand that difference. Okay, so there it is pictured. So again, in solids, they're usually formed into a what's called a lattice. All right, a lattice means that they actually interlock, and in that case, they are fixed in place. They don't move. They just wiggle in place, and that's it. Whereas liquid water will tumble all over the place and move all over the place and change places. All right. So as far as phase changes go, you're going to see a graph like this typically. So phase changes happen when things are heated up or cooled down. So if I take a solid material, heat it up, I'll reach certain temperatures, it will start melting. Then if you reach another temperature, it might start boiling. So that's an example of one. I'll show you the one with water because you guys are more familiar with that. This is another material, I'm not sure for what substance. All right, so to graph it out, I'm going to do it over on the smartboard. Okay, so for water, this is what the graph is going to look like. So I'm going to start out just as negative 10 degrees Celsius, which is below freezing. All right, and I'm going to start here as my time is this way. All right, so increasing. So if I go up the graph, right here, it's going to be a solid material. And then it's going to reach a certain point here in the graph. Okay, this point right here is what we're going to call melting point. So for liquid water, that's going to be 0 degrees Celsius. So once it reaches 0 degrees Celsius, we begin the process of melting. Okay, and then you're going to reach a point where all the material is now melted. All right, it became a liquid. Okay, what will happen then after that? And that's why we put ice in water, because it keeps the temperature constant for a while until all the ice is melted. Once the ice melts, the temperature will raise again. Okay, and then you're going to reach another temperature here. This is 100 degrees Celsius, and this is our boiling point. All right, when we reach our boiling point, so liquid is now changing into a gas. And as that happens, we have evaporation. Also known as vaporization. Okay. And then, obviously, once all the evaporation has occurred, you have a gas, and the gas will now heat up above 100 degrees Celsius here. And that's the end of our heating curve. Okay, and what will happen, the same thing will happen in reverse. So if I do the experiment in reverse, a gas will go back to a liquid, and this would be condensation. And then the liquid cooling down, you'll eventually reach a point where we remove all the heat, and now this is freezing. And then you end up being a solid once all the material has frozen. Okay, so that's the way the liquid water would heat up and cool down, and that's a graph that showing the phase changes over time. What takes more energy? Melting or evaporation? Well, you notice the time on the graph. Melting takes less time than vaporization or evaporation. So that's an important thing to know. It takes more energy to evaporate water than to melt it. Okay. All right, and as I mentioned, so we have our different phase changes. So this just goes over that in a picture sort of form, so you can kind of look at that. So again, solid to a liquid is melting, and then liquid to a solid, solidification or freezing. Okay, if you go liquid to a gas, evaporation, and gas to a liquid is condensation. And I mentioned solid changing to a gas is called sublimation, or gas to a solid is also sublimation in the other sense. So these are the phase changes, and hopefully you guys understand. If you have any questions, feel free to email me. But thank you guys for tuning in.